polygon because it is an enclosed shape. On the side, again, we have frequency. This is, again, the number of cats per house on Harrison Street. Now, when you're making a histogram, there's actually two different ways that you can mark your stuff, but this isn't a histogram, this is a polygon, so I'll wait for the next one. So we're going to do the exact same thing we did last time, where we've got these like kind of markers. This was negative 0.5. This one was 3.5.
Isn't this the one where you can make kind of like a bar that goes to the end? You know what I'm talking about? Does that make sense? So like with this one, you had to make sure that you didn't like just put the first bar to the end. Isn't this the one where you can do that?
No, the only reason why this is happening is because it's the negative 0.5. Yeah. That's not what the specific point of the graph is. Maybe I'm not understanding your question.
I don't understand what the question I'm asking.
Okay, we'll go back to that in a minute. Okay, the beginning and the ending of the graph touches the y-axis. I'm going to write down an extra point up here, so everybody write it too. Your point goes on the upper boundary. So my first one is starting at 0. And then my first class had 6 in it.
It started at -0.5.
Yep. I meant 0 on the y.
Oh, I see.
And then the second one is 6, so that's immediately gonna zoom up to 6. Here's a special trick of mine: if you miss a dot, just make the dot bigger. Then we're gonna go down to 2. This looks like a line graph, kind of. And down to 1. These should be straight lines, by the way, not just like, I mean, I know that you're trying to make them straight, but they should not curve. And then down to 0. Now, our last category happened to be 0, right? But let's say it didn't. Let's say the last category had like 5 in it. Then what would do is you'd make one more tally and then add another 4 and then bring it back down to 0. Because do you see how this is an enclosed shape? There's no empty parts, no gaps. That's what a polygon is. Okay, next one. Relative frequency histogram. All right, a histogram is a bar graph where things touch. Let's do this one fast. Sorry that this is boring, but it does have to be done. I'm excited when we get into the projects. Have you guys ever been interviewed for somebody for their project or done for a stats project? Has anybody ever had to like do something, like do a memory test or do like a basketball thing? It's really fun picking your sample. Okay. So can somebody tell me what the difference is between this one and the last one? Or this one and the first one on the first page? Instead of being a frequency histogram, this is a relative frequency histogram. So what's the difference?
Relative frequency.
On the side. Yep, on the side, it's a relative frequency. This is all about, so this one's gonna be like 0.1, 0.2, 0.3. Something that I was kind of shocked to find out from my last stats class, and not specifically the people that are in here. In fact, specifically the people who are not in here did not understand that this scale has to be even going up. As in, like, if you're jumping by 0.1s, they all jump by 0.1s. A whole bunch of kids were just, like, putting, like, the first number they saw, and then the next number they saw, and then the next number they saw, and then the next number they saw going up. No, like, it was, like, 8 people. Like, I've never seen it before, and it was so many people. Did you do it on the first test as well?
Yeah.
Yeah, that shocked me.
Well, 'cause
I've never seen that
they
one
didn't-
before.
I think it's because they didn't look the same, because we were rounding when he was up.
Okay.
So they weren't like the same. So we
Yeah.
just assumed it would. Also, we never had like any blank classes, I think.
That's
during
true.
that lesson.
Okay, so something that maybe we need to do, I'm gonna do this one this time. Do you guys feel like you understand the class boundaries? The edges of the things, the 0.5s, are we all good on that? Okay, so instead this time I'm gonna label stuff using midpoints. So this one is a lot easier to do if you do it after you draw your graph. So I'm gonna draw my bars first, which was 0.6. This should be exactly the same shape as the first one we drew, it's just decimals instead. And I hope that everybody realizes that even though my number was 6 and this is 0.6, those don't always match. It just happened to be that way because I had 10 in my sample. So anytime you're doing a histogram, you can also mark them by midpoint, which means you kind of put a line going down from the center of the bar and you write it right next to it. So the first one was 1.5 and 5.5, 9.5, 13.5, and 17.5. Remember that the label down here is cats, and up here was like cats per household on Harrison Street or whatever. It's a relative frequency histogram.
So it's optional to do the midpoints, right?
Yes, you could do midpoints or you could do class boundaries. Either one's acceptable. And if you always do midpoints, fine. And if you always do class boundaries, fine. But that only works on a bar graph like this one. This one has to be the upper and the lower boundaries. So if you want to save space in your brain, you can totally skip midpoints completely because you have to do class boundaries for this one. So if you want to do class boundaries for everything, you could. All right, last one is an ogive. I know that it looks like ogive, but it's pronounced ogive because it's super cool. It looks like a line graph, and it is cumulative frequency on the side instead.